As a part of the TENSOR project, THRIDIUM Technologies is developing a data-sharing platform with the express purpose of facilitating fast, intuitive, and most of all secure data exchange between different law enforcement agencies across Europe. Two of the core tenets during the design process were adherence to the utmost security standards due to the extremely sensitive nature of the data, and retention of the proper ownership rights by the LEAs themselves regardless of the underlying infrastructure. The above principles have raised the need to store user data in a secure way, using private and decentralized data stores directly governed by the data owner, regardless of the infrastructure provider. Alongside, this task introduces immutable records of the requests that are taking place by ensuring their secure distribution across the network. Finally, this implementation aims to integrate the functionalities of other tasks such as homomorphic encryption and the indexing mechanism. The defined challenges have led to the adoption of the SOLID protocol, an innovative state-of-the-art technology, used currently for storing social user data in a secure way, directly governed by the data owner regardless of the infrastructure provider. An important note for the rest of this presentation is that the SOLID protocol introduces the notion of a data pod, essentially an isolated data space inside the SOLID server, that acts as an autonomous file server, managed and owned by a single user. Many data pods can coexist in a single SOLID server and can interact with each other, as well as pods and users from other SOLID servers altogether. This solution is going to integrate the functionalities of Task 4.3 to store the required index and hashing data. Moreover, it is accompanied by a more true and tested Ethereum blockchain technology, leveraging its inherent validation and non-repudiation properties. Ethereum is a decentralized blockchain platform that executes and verifies application code, called smart contracts, to store access requests and responses, acceptance or denial. In this first version, the data platform exposes a REST API that can be consumed by both human users and other applications or services. The current functionality is focused around the SOLID component, and specifically, user management, file storage and retrieval, and handling access rights between different pods and users. The task plans to create added value by bringing together the transparency and trust of Ethereum blockchain with the security, speed, and robustness of a cutting-edge access rights management framework, SOLID. As depicted in this diagram, the data requester initiates a request, and this is recorded in the blockchain. The data owner has the option to respond affirmatively or negatively to this request. If the response is positive, the data owner temporarily adjusts the permissions for the requested resource. Subsequently, the data requester gains access to the requested resource until the permissions are revoked. Input data for the data sharing platform component is versatile, as the platform is data format agnostic. Users have the flexibility to store various resources, including images, videos, text, JSON files, and more, in their respective SOLID data pods. Furthermore, the stored data on the platform can include associated metadata, providing a comprehensive and customizable approach to managing diverse types of information. The actual exchange of data is the final phase of the system's operation and can be considered its main output. The output of this operation could manifest as the obtained resource, such as a requested file. Additionally, the blockchain ensures a secure record of transactions, encompassing data requests, provider responses, and data access attempts, providing an immutable and transparent history of the platform's interactions. Data sharing platform is a part of the third use case scenario. Law enforcement agency 1 user, acting as the data requester, initiates a new access request, incorporating details such as ID, sender, recipient, resource, timestamp, duration. This comprehensive request is securely stored in the blockchain. Law enforcement agency 2 user, serving as the data grantor, receives a notification and responds by generating an acceptance response. The response includes ID, matching the request, resource path, timestamp, data encryption key, and like the request, is securely stored in the blockchain. The grantor proceeds to adjust the access policy for the specified resource within the SOLID server, enabling read access for the sender for the specified duration. Utilizing the received resource path, the requester retrieves the agreed-upon resources. This retrieval process can be repeated multiple times until the access duration expires. Each attempt to access the resources triggers a recording in the blockchain, ensuring verification by both LEAs. To decode the received data, the requester employs the retrieved key. Upon the expiration of the access period, the grantor is notified and promptly reverts the resource's access policy to its previous state. This systematic process ensures a secure and controlled exchange of resources within the defined access parameters. The data platform exposes a REST API that can be consumed by both human users and other applications or services. The current functionality is focused around the solid component, and specifically, user management, file storage and retrieval, and handling access rights between different pods and users. The best way to describe the functionality would be an example. So we would like to describe two different flows, pertaining to the registration of a new user along with the creation of their personal data pod, and the exchange of a single file between two LEA officers. Starting off with the registration, the pod administrator shown in the left window, a special account created at the initialization of each specific data sharing platform instance, must initially trigger the post@/register endpoint and provide the necessary information on the request body. After this step, the new pod is created and the new user shown in the right window can log in via the get@/login endpoint, which will redirect the user to the environment of the identity client specified. Finally, the newly created user can trigger the get@/initialize endpoint to perform the necessary initialization operations. This process may seem a bit counterintuitive at first glance, but exemplifies one of the core values of the solid protocol, data ownership. From the moment of its creation, the pod is managed by the data owner, and not the pod administrator or the infrastructure provider. This means that while the data sharing API can and will provide some automatization for the user's convenience, the final decision regarding any data operation inside each pod is solely up to the pod owner. The next and main part we'd like to showcase is the data exchange flow. To initialize this flow, both the pod owner, shown on the left, and the data requester, shown on the right, must log into their respective identity providers. After successful authentication, the pod owner can use the post@/resources/path/to/upload endpoint, providing a file to upload and optionally a different file name or a different MIME type, in case of highly proprietary file formats that are not auto-detected. The next step is for the data requester to perform the actual data request, which is not currently implemented, but will be stored securely on the blockchain. The pod owner is notified of this request and writes on the blockchain the appropriate response, detailing the specifics of the data transfer, time window of the access rights, data decryption keys, etc., while simultaneously triggering the post@/access/read/resource/user endpoint to provide read access to the requesting user. While the requester has read access, they can use the get@/resources/path/to/file endpoint to retrieve the file specified. After the data access expires, or manually, the pod owner can use the post@/access/read/resource/user endpoint again to revoke the read access provided, after which the data requester cannot perform the retrieval operation, due to missing permissions. Finally, both the pod owner and data requester can use the get@/logout endpoint to log out of their current session. This has been the first Tensor presentation of THRIDIUM's data sharing platform. Thanks for watching.